We're going to do a quick on inverses. So you already know a lot about inverses that you probably don't realize that you know. For example, you know the inverse of addition is subtraction. The inverse is just what undoes something. So the inverse of multiplication is division. The inverse of squaring something is doing the square root. So you know lots of different things already about inverses and how to undo different types of things. So today we're going to be talking about doing inverses of whole functions. Okay? So I have an example for that, kind of a real life scenario thing that we're going to look at first. And so I'm going to wrap this present, so just a granola bar, for my present. So step one, I'm going to put it inside of the box. Okay? Put into box. Okay? Then, step two, I'm going to put the wrapping paper. Number two, wrap the box. Now we're going to put on the bow. Step three, add the bow. Actually, I'm going to change that. Tie bow around box. So now we have our nice present that's wrapped, and we're going to figure out how to do the present, get the present out of the box. And so that's what we're going to be learning next. So now I have someone here to give my present to. So I'm going to give my present to Juniper, and she's going to open the present. So Juniper, what's the first thing you have to do when you open the present?
You have to untie the bow.
Untie the bow. Okay. So step one of the inverse, when we undo something, it's called the inverse, is to untie the bow. Untie the bow and remove it from the package. Okay, then what are you going to do next?
Unwrap the wrapping paper.
Okay, so step two, she's going to undo the wrapping paper.
Mom, what did you use on this?
3 bits of sticky tape.
Gee, that was hard. Bye.
Okay, and then what's the last thing you're going to do with your present?
I'm going to open the box.
And what else are you going to do when you open the box?
I'm gonna get out the present.
You're going to get out the present. You got a granola bar. All right.
At least I needed that.
You needed that?
Breakfast.
Okay. Oh, you didn't have breakfast? Well, good. I'm glad you got a granola bar.
I
So,
did.
you did have breakfast.
Not very.
Okay, so I'm going to write down the third step here. Is to open and remove present from box. So that's it.
Goodbye.
To undo, did we get to undo putting the granola bar in the box first? Could you have done that first? Could have you got the granola bar out of the box without untying the bow and unwrapping the wrapping paper?
No.
Could you have easily unwrapped the present without taking the bow off first?
No.
No. Right? You couldn't get the wrapping paper off without getting the bow off, especially because I did the kind of bow that ties up around the outside, huh?
No, that would still be easy. Oh, no. No.
Okay. So,
The box is
we
open.
have to undo in the opposite order. We have to untie the bow first, then unwrap the wrapping paper, then we can open the box and take the present out.
It's repeated.
That's how inverses work. We don't get to go in the same order as the original. We have to go in backwards order of the original and undo each step in backwards order. Okay, so now let's go try that with some equations, with some numbers, with some functions. All right, so just a quick review. We put the present in the box, then we wrapped the box, then we tied the bow around the box. Then to undo the present, to take the present back out, we didn't get to start out by taking the present out of the box. We had to undo step 3 first, untie the bow, then unwrap the box, then we could undo step 1, open and remove present from box. So when we do the inverse, we undo everything in the opposite order than we did it in originally. So let's try this with just some math steps. Okay? So here's my original. Step 1 is multiply by 5, step 2 is subtract 8, and step 3 is divide by 2. So for my inverse, first thing I undo is step 3. Undoing dividing is multiply. So I'm going to multiply by 2. Then I'm going to work my way back up. I'm going to undo subtract 8. Add 8. Keep going. Undo multiply by 5. Divide by 5. Now we're going to actually look at these as functions. So this is g of x. We start with x and we multiply it by 5. So x multiplied by 5 is 5x. Then we take the result of that and we subtract 8. Then we take the result of that and all of it gets divided by 2. You can't just put a little like divide symbol 2 here, or it's only dividing the 8 by 2. You got to make sure the whole thing gets divided by 2. Our inverse function, g inverse of x, that's what this little -1 right here means. It means inverse. It means the undoing, okay? It doesn't mean a -1 exponent when it's here with a function like this. It just means inverse. So g inverse of x, multiply by 2, so that's 2x, add 8, and then divide everything by 5. Oh, you can't see that. There we go. Multiply by 2, add 8, divide by 5. Okay? So we're going to try another one now. Let's look at n of x. That where you can see it. And let's look at the steps we would have here for n of x. Step 1. If I knew what this number was, first thing I do is multiply by 4. Second thing I would do is subtract 12. So multiply by 4, subtract 12. So for the inverse, I'm going to reverse the process and undo everything. I'm going to undo subtract 12, which means I'm going to add 12. I'm going to undo multiply by 4, which means I'm going to divide by 4. I'm going to see this next problem. That's okay. And then so I would write that as n inverse of x. The inverse of this function is add 12 first, then divide everything by 4. So my inverse function is x plus 12 all divided by 4. So I want you to try this next one. Try this j of x on your own. Pause the video for a minute and see if you can do j of x by yourself. Okay, now that you've had a chance to try it, let's do it together. Make sure you did okay on that. So my first step here, if I knew what x was, is I would subtract 7. And then my second step would be to divide by 10. So over here, we're going to do the inverse. We're going to start by undoing divide by 10. So multiply, just do that, by 10. Step 2, add 7. So when I write this out, it's j inverse of x. Since this was j, it's j inverse. J inverse of x equals 10x plus 7. Hopefully you did okay on that. I'm going to give you some more chances to practice in just a couple of minutes. But first, we're going to look at another function, h of x. And we're going to look at this using tables and using a graph. Okay? So I'm going to start my table here. Just going to put in some values for x in my table. If I plug in negative 2 in here, 2 times negative 2 is negative 4, minus 1, negative 5. Plug in negative 1, I get negative 2 minus 1, which is negative 3. Keep going, and I can get all of my numbers for my table. Now, if I go to do the inverse and make a table of the inverse, I need to actually write down what my steps were so I can figure out the inverse. So step 1, right here, would be multiply by 2. And step 2 would be subtract 1. Multiply by 2, subtract 1. So for my inverse, if I'm going to undo this, the steps for the inverse are a little bit different. Step 1 undoes my last step here. It undoes step 2. Add 1. Then the second step will undo this step. So divide by 2. You can't see that. Sorry. So the inverse is add 1 and then divide by 2. Okay. So if I'm going to write the equation for that, my equation was h, so this is h inverse of x equals, add 1 first, so x plus 1 divided by 2, all divided by 2. So I'm going to put some numbers here to plug in for x into my inverse function. Negative 5 plus 1 is negative 4, divided by 2 is negative 2. Negative 3 plus 1 is negative 2, divided by 2 is negative 1. Negative 1 plus 1 is 0, divided by 2 is 0. And 1 plus 1 is 2, 2 divided by 2 is 1. 3 plus 1 is 4, divided by 2 is 2. So the reason we wanted to make a table is so we can see this connection between inverses. All of the outputs in this table are the inputs that I chose for my inverse table. And I want you to see what happens. The inputs here now match the outputs here. With inverses, the inputs and the outputs trade places. So when the input here is negative 2, the output's negative 5. If I switch on the inverse and put the input as negative 5, the output is negative 2, and so on. So I could have actually just made this table by just flipping the inputs and the outputs from this table to my inverse table. And you can see that that's the case by actually using the equation and figuring it out. So let's graph both of these and see what they look like. 2x minus 1 has this y-intercept at negative 1, a slope of 2. I also have all these points in this table that I could use if I want to kind of help me with getting a few points, just so that I can make sure I have a nice, good line here. Pretend that's all straight and everything. It's not very good. But that's my line. And then for the inverse, again, I have points, or I do have the function. This is just a linear function. I can divide by 2 on each piece individually and see its slope is 1/2 and its y-intercept is also 1/2. I'm just going to use these points, but we'll check and see that that all works out here in a minute. All right. So there's my line. So you can see it crosses here at 1/2, and it also has like that up 1 over 2 slope. So the thing about inverses and their graphs is that they're always going to cross at a point where the x and the y are the same. In this case, 1, 1. because when we switch the x and the y places with something like 1, 1, we get 1, 1. Since they're the same number, when they trade places, it stays the same as it was before. So this line and this line cross there. And there's this line that goes through every point where x and y are the same. X equals y, this line, or y equals x, where they're the same. It's symmetrical across that line, because that's the line that is where we trade. If we traded the x and the y's places, it would look still exactly the same. Okay? So that's some cool things about how graphs and tables work with inverses. We're also going to look at the intercepts here. Here I have a y-intercept of over 0, down 1. You'll notice that that matches up with the x-intercept of the inverse, because inputs and outputs trade places. Y's and x's trade places. So now it's -1, 0. It's an x-intercept here at -1, 0. The same thing happens with the x-intercepts. Here's my x-intercept. It's at 1/2, 0. When I trade the x and the y places, I end up right here, 0, 1/2. And that's the y-intercept for the inverse. All right. So what I want you guys to do now is go ahead and try these next two problems. You don't need to graph them or make tables, but just try writing out the steps and then coming up with the inverse. So go ahead and pause and try it and then come back. All right, now that you've had a chance to try it, I'm going to just give you what the final solution should be, and then we'll go back and look at the steps here in just a second. So this one, F inverse, is going to be x minus 3 divided by 2. Hopefully you got that. If not, we'll go through it just in case. G inverse is 4x plus 5. If you got both of those, you're good. Hopefully you kind of got it and you'll be able to do your assignments. If you didn't get those, go ahead and keep watching and I'm going to explain how I did these. So for this one, my steps were multiply by 2, that's right here. Step 2, add 3, that's right here. So for my inverse, I have to undo adding 3 first. So subtract 3. Undo multiplying by 2 second, so divide by 2. So you can see that's what I did right here. Subtract 3, divide by 2. Let's look at this last one right here. Step 1 is subtract 5. Step 2 is divide by 4. Now, if I go back and undo these in the reverse order, undo step 2 first, multiply by 4, and then I undo this one, add 5. That's how I got this inverse. I did multiply by 4, add 5. Please feel free to contact me or Mrs. Jones if you have any questions, if you need help with any of this. We're here to help you. We'd be happy to either respond over email or do a video call or a voice call or whatever you need. Good luck, and hopefully things go well.
Unless I had scissors and then I could do that and then go.
Yeah.
But I didn't have scissors. Could I have used scissors?
No.
Aw.
Okay, so could you have unwrapped the wrapping paper before you untied the bow?
Yes, I could have.
Pretty easily? What's the best and easiest way to unwrap it?
By grabbing the paper and then pulling it